Hello everyone. So from this tutorial I'm going to talk about multiplexers which we used in electronic circuits. So initially we have 2 by 1 multiplexer, and later on we will be discussing 4 by 2 multiplexer. So what is a multiplexer? Multiplexer means many into one, right? There are many signals, it will be converted into a one signal. Not be converted, it will pass only a one signal. A multiplexer is a circuit used to select and route any one of the several input signals to a single out. So there will be several signals to input into this device, and within a routing or else the switching using a switching or a routing the indicator, it will switch the values and it will be sent to this output. You think this is the switch. From this switch there's a part to here, another one to here. So it has the capability of changing the outputs. Switch is the main thing that controls the mux. We call this one as also a mux because it's a multiplexer. We call this one as a mux. So a simple example of an non-electric circuit of a multiplexer is a signal pole multi-position switch, right? Then the advantages. So it reduces the number of wires. So for a circuit, if there are many wires, we can reduce it to a one using this multiplexer, and it reduces the complexity of the circuit and it reduces the cost. We don't need to lay a lot of wires. So this is the 2:1 multiplexer. So because there will be two inputs to there, right? Then after I'll be talking about 4 by 2 multiplexer. There will be 4 inputs to the multiplexer, but in multiplexers the output is always 1. For the multiplexers the output is always 1. So here I have a selector here. Even though the outputs are coming from this side, the selector is the only one who is going to choose the input, and that input is transferred as the output. Selector is the only one who is going to select. So when the selector value is 0, here you can see when the selector value is 0, it passes I0 value. When S is 0, when the selector value is 0, it passes this one. It ignores this value. It ignores this value. Whether is it 0 or 1, it doesn't pass. If 1 comes here, it doesn't pass. It passes only this value. Similarly, if S is equal 1, then it will pass only this value as the Y. It won't take this one into consideration. It won't take this much this bit into consideration. It consider only this one and put output as 1. So the logic gate comes as like this. S is 0, I is 0, I naught. S is 0. You can see S is coming, S bar. S bar is coming, I naught. S bar, I naught is okay. S bar, I naught. Then I naught, I1. I naught is coming. Sorry, I naught is coming. Sorry, initially I did S0, I naught. S0 is this one, I naught is this one, okay. Then 1 and S is 1 and I1. S1 is coming from here, I1 is coming from here. From both together there is a O gate. From that O gate the plus 1 will be transferred, right? So let me move on to the my logism interface. So here you can see my canvas. right? So I'm gonna start drawing my uh, 2 by 1 multiplexer. Initially I had two AND gates, two AND gates and one OR gate, two AND gates. I need to reduce the inputs now to number of inputs as 2. I copy pasted it. Okay, my two AND gates are ready. Then so it's okay. My two AND gates are okay. Then I'm gonna choose OR gate. The number of inputs should be 2. And I'll be connecting this OR gate. There will be one input from here, right? And there will be another input. This one, this input. It comes like this, comes like this, right? So from this one, I need to connect to a NOT gate, because can you remember we had a NOT gate here. So one should be a NOT gate. This one comes like this. I need a NOT gate. I connected my NOT gate to here, and then this NOT gate is coming like this, and this should be connected with this NOT gate. This is my S line switch on. This is a one switch. This is the switch. Switch is the on state, switch is off stage. Switch is on, switch is off. So I will name this one as my switch. Right. Then I have the inputs like these two inputs. I had two inputs. One input from here, one input from here, and then I need to add a display pin from here. Okay, and I need another switch for its S value, switch value, and I need to heading towards north. This should be heading towards north. Okay, now my circuit is almost complete. I want to name these icons actually now. So this is my switch S. This is my I0 value. This is my I1 value. Right, I'll show you. You can see I0, I1. This is I0, this is I1. This is my I0 value. This is I1 value. Okay. This is my output Y. Similarly, this is the simulation using logic gates. So I have completed my circuit now. Also, I can regenerate this one using from here. You have an item called plexers. Rather than using this logic gates, there are plexers. From here we have multiplexers, demultiplexers, decoders, priority encoders, bit selectors. Right? From here I'm going to select these multiplexers. I'm going to place it here. So I'm going to double click on this one. Number of bits is 1, data bits also 1, it's okay. And then I'm going to mark the output. The output is come from here. So I'll take one out like this. I will add the pin, display pin, right? So then after, the selector tool is out of these two, where there is a dot here, this is the selector tool, select a button. So I will be putting a button in here also. Thereafter, I have two inputs. I have I1 input, I0 input. Similarly, I have these two inputs. This is the input 1. This is the input 0. Right? This is the input 1. It means this is I1, this is I0. I have added another pin. Okay. Then let me name these items. So this is the 0, 0, 1. It is I0, input 0. So let me label this one as I0. This is I1. Okay, now my this is select. What is the switch? Actually, this is the select. Select a switch. This is select a switch. This is also the same. So let me begin the simulation. So if we refer our truth table, from here you can see, right? I'm going to start my simulation. If selector is 0, it will pass the I0 value. If selector is 0, it will pass the I0 value. Now my selector is 0, right? It will pass the I0 value. My selector is almost 0 now. Then it will pass the I0 value. This is the I0 value. Okay, I0 value is the output. It is 0 now, 0. Let me change this one to 1. Okay, if this is 1, this is also 1. Satisfied. It don't care about whether this is on or off. See, you can see it here. Even if I on, nothing will happen. Nothing will happen. So I'm going to switch off this one. Now the condition is, if the selector is 0 here, selector is 0, it will pass the I0 value. Selector is 0, it will pass the I0 value. There will be no problem if I switch on or off this one. It will neglect. Right? Similarly, this is the same thing, simulation for this one. If the switch is 0, it will pass, right? I0 value. I0 value is this one, upper one. If I make switch on this one, it will pass. If I switch on this one, nothing will happen. It only passes this one value to here, right? So if I switch on this one, nothing will happen. Similarly, let's go to the second stage. When S is equal 1, it passes the I1 value. When S is equal 1, it passes the I1 value. When S is equal 1, okay, 1, 1, it passes the I1 value. Where's I1 value? Here we have I1 value. So this is the one value which passes to here. Let me check. If I change this to 1, this changes to 1. If I change this one, this one, it changes to 1. I1 value is passed. I1 value. Right? So this is 2:1 multiplexer. Multiplexer reduces the number of inputs. It outputs only one output. So when there are several signals incoming to this signal, so this is the multiplexer circuit. If there are several signals input to this multiplexer called mux, a short term mux, there are several signals, it will generate only one output considering the switch, considering the status of the switch. Switch is the only one who routes, actually switches between these two lines, right? This is a 2:1 multiplexer. So let me move on to the 4:1 multiplexer. So in 4:2, actually 4:2 multiplexer, the circuit diagram is as follows. 4:2, 4:2. So 4:2 multiplexer, it indicates when there are 4 inputs here: 1, I0, I1, I2 and I3. We have 4 inputs, I0, I1, I2, I3. These 4 inputs will be switched and output as a one output. That's the result actually from a 4:2 multiplexer. We call this one as 4:2 multiplexer because we have 4 inputs: I0, I1, I2, I3. These are the switches S1 and S2. Switches can be on state, switches can be in off state. Switches can be in on state, switches can be in off state. So this is the truth table. If both switches are off, it will pass the I0 value directly to the as the output. If one switch is on, other switch is off, it means S1 is off, S0 is on. S1 is off, S0 is on, it will directly pass the I1 value. Similarly, if both switches are on, it will pass I3 value. Right, let me go on to the simulation process. So what I need is I need 4 AND gates which comprises 3 inputs. I need 4 AND gates. I'm gonna copy paste. And now I have 4 AND gates, and those 4 AND gates should be connected to an OR gate. In the OR gate, I need 4 inputs because one input from here, one input from here, one input from here, one input from here. Go to double click, reduce the number of inputs to 4. Then we can connect this one like this. At last you can connect this one also, and you can take the output from here. This is the right side, so I need to have the screw switches from here, switches line. So let me take a wire and I'm going to draw my switch like this, and I need a NOT gate to indicate the off stage of the switch. So it should be heading towards south, and then I will turn this on like this. I will connect it to here and I will make it down like this. Similarly, I need the same copy of this. So what I can do is, I have two switches. I'm going to select everything, just copy and paste. You will have another one. You can keep it from here. Then initially I need to shift this thing a little bit up because okay. So initially one of the input is this, one of the input for multiplexer. These are the inputs. The topmost bits are the inputs. So let me take inputs like this. These are the inputs. So these are the inputs. I will name this one as I. Can you remember? This is I0, I1, I2, I3, like that it will come, right? So let me label this one. This is I0. This is I1. This is I2. This is I3. So then after, I need to connect the other parts. In the first AND gate, it is connected, and also first of all I would like to make the inputs of these two also. I will keeping an input here, and I will make the heading to south, and I will join it here. I need a copy of that. Okay, and I'll name this one as S0. This is my S0 one. This is S1 switch. So these two switches should be connected to these. My inputs are okay now. The switches, from the switches only these inputs are selected, right? So I need to connect. So let me show you the diagram. For the initial gate, it is S bar, S1 bar, S0 bar. Here S1 bar and S0 bar. S1 bar is coming from here. S0 bar is coming from here. Similarly, I can join the other parts also. For the other parts, I have S bar and S1 bar and S0. For this one, I have S1 bar and S0 as the output, S0 is as the input. For this part, I have S1 as one input, the other input is S naught bar. Other input is S naught bar, like this. So the last part I have an input from S1 and the other input is from S0. So I will erase these unwanted parts. Okay, now you can see for S1 line there are two inputs connected, S bar line two inputs connected, S0 line two inputs connected, S0 bar line another two inputs are connected. Let me display the result. This is 4:2, 4:1 marks. So in this case, let me show you the truth table. From here, I'm going to start my simulation. So initially, when S1 is 0, S0 is 0, S1 is 0, S0 is 0, it passes the I naught value, I naught value as the output. So I naught value is this. When the switches are off, I naught value is this. I naught value is the passed value. You can see it from here. If I make this as 1, this will get passed as 1 as here. So when these two are off, right, if I switch on other one, nothing will happen. See, it only passes this I0 value when the both switches are off. Let me move to the second stage. It passes I1 value to the output if the inputs are 0 and 1. If S1 is 0, S0 is 1. S1 is 0, S0 is 1. S1 is 0, okay. S0 is 1. S0 is 1. Okay. When this happens, they say is it passes the I1 value. Now I1 is this one. Let me check. If I switch on this one, there should be a 1 here. You can see even I have marked this as 1, then this is also 1. Even though if I have marked this one and this one and this one, nothing will happen. So out of these 4 bits, from the switches, it switches and it passes only this value as the output. Right? This value. I1 value as the output. Out of these 4 values from the switch, it outputs only this value. Similarly, I'll take I2 value. If the switches are 1 and 0, the switches are 1 and 0, it will output the I2 value. They don't care about the other values. It will output the I2 value. Right? Now I2 value is 0. It is the output. If I make this as 1, you can see I2 value is the output. It doesn't output these things. Even if I switch on this one, they ignore these things. Right? Similarly, the last stage, if both switches are on, it will transfer the I3 value as the output. I3 value is here. I3 value is the transferred value to here. So you can see if I switch on this one, this will be marked as 1. Even though if I switch on these other three switches, nothing will happen. By switching off this one, if I switch on these three, then also nothing will happen, because the priority is given to this. So this is the simulation of multiplexer 4:1 multiplexer. This is 2:1. Similarly, you can generate 8:1 multiplexer. So how we do the multiplexing process is, the number of inputs will be reduced into one output. So this is the scenario of number of inputs and number of outputs regarding the multiplexers. So thank you all. Hope you all got understood. Thank you.